we're on day 5, applications of vectors, which was our final lesson for this vector unit. Quite a short unit, which is good, especially if you don't like vectors. But what we're going to do in this final lesson is going to solve application problems involving vectors. Okay, so at the beginning, on these very first couple slides, we're going to look just at some definitions of what a force is. Okay, if you understand what a force is, you've taken physics before, you don't need to write these slides down until the examples at the end of the lesson. Okay, but a force is a push or a pull on an object resulting from its interaction with another object. Okay, when the interaction ceases, the object no longer experiences a force. If the force exerted on an object at rest is great enough, the object will move. Okay, so usually with what we're looking at in vectors is when we're having that object move. Okay, so a force is a vector quantity, meaning that it has both that magnitude and the direction. Okay, so a lot of the time in application problems, you're going to hear a force of 312 newtons is exerted on a bicycle or whatever it is. So you just need to understand that's what they're meaning by force, that it is a vector quantity, okay? And it is both a magnitude and a direction. When you have a resultant force, in problems that we're going to be solving, most of the time we have often the case of 2 or more forces that are acting upon an object at the same time. So we will have that in some problems, okay? If this is the case, we can find a single force that would produce exactly the same effect as all of the original forces acting together, okay? So again, that's kind of like saying, remember when we had a force going this way and a force going this way? Well, we can find that resultant force going this way. Okay, so you just have to keep in mind then we used our parallelogram method. Okay, so that is what this is talking about with our resultant force. Okay, the force is called the resultant force or the net force. Okay, it is the sum of the forces acting on the object. So again, remember this was like V, this was W, well this is V plus W. So then we could find that resultant or net force, okay, by adding them together and finding the sum. Okay, so the resultant of several forces is a single force that can be used to represent the combined effect of all forces acting on an object. Okay, component forces are the individual forces that make up that resultant force. So remember, our component forces were the horizontal and vertical components. So this shouldn't really be super new, it's just kind of putting it in words on paper for you, okay? Equilibrant forces, of several forces, is a single force that opposes the resultant force, okay? When an equilibrant force is applied to an object, this force maintains the object in a state of equilibrium. If the resultant force results in movement of the object, application of an equilibrant force to the object will keep it still. Okay, so that's like opposite or opposing our resultant force, which you may see in some problems. Okay, so just understanding the terminology there. So if you didn't write anything down, that's fine. Just make sure that you understand what like the resultant force is, net force is, what an equilibrium of several forces is, all of that stuff we just talked about. Okay, so here is one example. So forces as vectors example problems. So our first one is 2 forces of 25 newtons and 40 newtons act at an angle of 32 degrees to each other. Determine the resultant of these 2 forces. Okay, so we actually have done an example like this before. So you're going to start by just drawing 25 newtons and 40 newtons acting at an angle of 32 degrees together. So if you want to go like this, doesn't really matter how you draw it. Oops, that's 25 newtons. And then you have 40 newtons. Acting at an angle of 32 degrees together. We want to determine the resultant force of these 2. So resultant, you're going to want to find the 25 plus the 40 newtons added together. Okay, so let's call this one our force 1, because doesn't tell us in the picture or in the word problem, and let's call this force 2. Okay, so your resultant is going to be F1 plus F2. Okay, so remember, using our parallelogram method, you're going to transcribe. So let's transcribe force 2 onto from the tail onto the head of force 1. So you're going to get something like that, force 2, okay? And then you're going to take force 1 and transcribe it onto the head of, I need to draw this longer, sorry, didn't do a very good job. There we go, that's better, okay? Then you're going to take force 1 and transcribe it onto force 2 here, like this. Not the best diagram. You can probably do better in your own notes and with actual pencil or pen. Okay, so remember that we were given some strategies here. So we can use our C pattern. Remember, our C pattern is here because we have parallel lines, right? This is parallel to this. This is parallel. This is parallel to this. Okay. So we can use our C pattern, and it's going to be 180 degrees minus that 32 degrees, and then we can figure out what this angle is here. So that angle is going to be 148 degrees. Okay, and then you can use your cosine law. Oops. Then you can use your cosine law to figure out this resultant force here that is going to go through our parallelogram. Okay, so if you want to draw it separately because it's getting a little too busy for cosine law, this is essentially what you have right now. You have 25 newtons. Our F2 is 40 newtons. We know this is 148 degrees. We don't know what, this is not dividing 32 exactly in half, so don't think that is like 16 degrees or anything, okay? So make sure you're using the angle of 148 from that C pattern, okay? And then this is our F1 plus our F2 that we're going to find, okay? So you can do it like this. F1 plus F2 is going to be 40 squared plus 25 squared minus 2 times 40 times 25 times the write it on a separate line of 148 degrees. Apologize, that's supposed to be one line, okay? So then the absolute value of F1 plus F2 is going to equal, so we're going to get 40 squared plus 25 squared, so 2225. And then I'm going to do this all in one step, so 148 times 2 times 40 times 25. It's going to be negative 169. 1,696.1. Okay. Then you're going to add the 2,225 plus 169. 1,696.1. So you should get 3,921.1. Sorry, and I also forgot to square this. Okay, so then when you take that absolute value of F1 plus F2, square it. Make sure that we're going to square root it now. Still the absolute value, and you're going to get 62.6. Okay, so there is your resultant of the two forces. Okay, that is that question there. We have done one like that before. Okay, so our next example with a force as a vector. is Sam pulls on a rope attached to a sled, which is carrying his sister. He pulls with a force of 275 newtons at an angle of 15 degrees to the horizontal. Determine the horizontal and vertical forces acting on the sled. Okay, so let's take a look. Let's draw a sled. Very basic sketch of a sled. Okay, then you're going to have your rope here, and let's say that this is Sam over here pulling on that rope. Okay, so you are going to be able to figure some information out here. Okay, based on the information given, Sam is pulling his sister at a force of 275 newtons. So this rope is going to have a force of 275 newtons in it. Okay, then this is actually, because it says from the horizontal, we are going to be able to draw that triangle there. And you know that it is 15 degrees from the horizontal. This is your horizontal here. Okay, remember it's like your horizon where your sun sets or sun rises. Okay, so it's 15 degrees up from there. Okay, so what we want to do is determine our horizontal and our vertical components. So what we're looking for is our x here and our y here, because x, remember, is horizontal, y is our vertical component. Okay, so when you're doing that, we're going to determine our absolute value of x, which is our horizontal component. Okay, and then we will do our y as well, which is our vertical component. Okay, remember it's going up and down, so vertical. You just have to remember those formulas. So remember that it was v cos of theta for this one, and then if this one is v sine of theta. So you're just going to put in 275 newtons cos of 15 degrees here, 275 newtons sine of 15 degrees here. So this one should be 265.6. And then remember that it is newtons. And then this one is going to be 71.2 approximately newtons. Let me make sure I did my math on that first one. Yeah, perfect. Okay, so there are your horizontal and your vertical forces acting on the sled. So you know that this one would be 265.6, and then that y is 71.2. Okay, so there's another problem with a force in it, and we're just finding our vertical and horizontal, or before we found a resultant force. Okay, so lots of questions in your homework there tonight. Question 1, 2, 9, 10, and 15. So just let me know if you have any questions with those. It's putting together basically everything we've done so far, but you will have probably seen some of these questions in previous homework, which is nice. So just let me know if you have any questions, and good luck.